Hey everybody, this is Larry. This is day 6 of the Leetcode Daily Challenge. Hit the like button, subscribe button, drop me on Discord. Let me know what you think about this one. I also just realized that, it's February, so I know that there's 28 days, but it's just like a fit in the perfect rectangle. Okay. I don't know how often that happens or whatever, but it's just kind of interesting to see. Anyway, we have another problem that's, and I'm telling this by the problem number is from a more recent contest. August, I guess it's like half a year ago, but it still feels recent. Like, are we up to 4,000 yet? Probably not, right? But I don't know. It just feels like I just did this video the other day or something, but I don't remember the problem, so I guess we'll see. Anyway, yeah, let's take a look at today. Let's go. I banged up my knee a little bit, so I'm like limping today, so not much exercise. Life is like that some days. So is my while we're talking about that, so is my stock portfolio. I guess that took a thing too. That's also not so happy. But you have up days, you have down days. All you can hope for is your up days are better than your down days. In my case, maybe not. But yeah. Man, wow. Okay. Anyway, let's take a look at today's problem. We have 3634 minimum removals to balance array. You give an integer array nums and an integer k. An array some considered balance of the value of its maximum element is at most k times the minimum element. You may remove any number of elements from nums without making it empty. Return the minimum number of elements to remove so that the remaining array is balanced. Okay. Yeah, with these kind of problems, you just have to kind of figure out how to phrase the question that you ask. And sometimes it is just n is going to be big enough that you're not doing n squared, just to be clear. And then the question is, okay, you're not doing n squared. You want to do something O of n, maybe n log n, right? Those are the two things that you want to do whenever you see n is equal to 10 to the 5th. And when you have those two things, then, obviously this is not always the case, but the first thing that I look for is, can I, given one element or one thing, like it could be one sub window or sub array for sliding window or something like that. But given one thing, can I do another thing in log n time, right? And for this particular problem, there may be two ways you can think about it, right? Or two standard way, right? Is that, okay, let's say if we're given one number as the minimum value, how many numbers, and you want to make it balanced, then what does that mean? Well, if it's minimum, then you remove everything smaller than it, and you remove everything that's k times the minimum number, and so you remove that, right? So it's kind of like that. You could do it in both directions. And of course, if you do a binary search for every minimum, that's going to be n log n. But of course, the other thing notice is that when you move the minimum, well, you can also move the maximum, and they're all kind of moving in concert, or together, if you will. So, and that gives you an idea for two pointer, right? Like, so you could do. In general, I am lazy about two pointers, or rather, and just to be clear, during a contest, I am lazy. Not lazy, it's just that it's easier to have off by ones for me, right? Like, I'm not saying that this is always the case, or in general even, but for me, like, I don't know, I'm just really bad about certain things, and so I will optimize, or I would rather be log n slower than, because during a contest, your goal is not to have the best algorithm. The goal is to finish as fast as you can in the constraints allowed. And that means that n log n, usually, especially if you have a lower constant, it's going to be the same of O of n because they both pass. So for me, during a contest, and that's probably, that's probably what I would have done in the contest, is that I just do an n log n solution. You just take a minimum binary search, or you can take the maximum binary search. I would think I actually would choose the maximum, do a binary search, because it is easier to use a bisect left to get the smallest element that is at least x or whatever, right? Because then you can remove the index will give you the number, and it's very easy. Where if you get the maximum, I guess even the maximum is fine, right? Yeah, I think it's the maximum is fine, but I think minimum is just, for me, more straightforward. But today, I suppose we will try to do sliding window, right? Technically, it's two pointer. I think it's more precise, even though I know sliding window is very similar to a lot of people. But of course, we also need to sort, right? We're going to do that. So Oh yeah. So I guess maybe I did lie about O of n anyway, because it's O of n after the 2 pointers, but then by the time you do sorting, it's gonna be n log n anyway. So you're not complexity wise, you're not doing any better. But yeah, so maybe I am lazy. I mean, I am lazy in a way, but sometimes, especially when I'm doing these videos, but for me, just like in general, it's okay to practice certain ideas that I know I'm bad at. And for me, it is 2 pointers. So let's do 2 pointers, right? So here maybe we have left is equal to 0. How do I want to write it? I mean, I think it's fine, right? I mean, you could do it the other way. Let's just say right is equal to 0 for left in range of n, right? And here maybe we annotate left or num sub left is min, num sub right is and you could be precise. The reason why sometimes you get off by 1 is because you're not precise of how you're thinking about it. At least for me, anyway. And this means that it could be is max, or because you get a choice, and sometimes you don't realize you make a choice, and then that's when you get confused. Because another choice that you can win is num sub right is the first number that is bigger than max, which is of course min times k, right? So, and those two things are kind of like the difference between inclusive and exclusive, right? Choosing inclusive and exclusive bound, and there's no right or wrong idea. It's just one is you just have to make sure you understand which one you chose explicitly, so that you can, when you have questions of off by 1, you know exactly which one you chose, and then it'll answer questions for you. The other is, of course, if you work in which is not the case for Leetcode, but if you work on a bigger code base, then everyone should, or all the code should be consistent, right? For me, it honestly doesn't really matter which one you choose, as long as everyone choose the same one. Like, you don't want half your code in a bigger code base to do one thing and then the other half in another thing. Then when you read the other code, it'll just feel so unnatural, or at least like it becomes like a bit of a smell and asymmetry, right? So those are the things that I would worry about. But yeah, so then now why and maybe I will choose this one, because then now I can write while right is less than n and num sub right is less than or equal to num sub left times k, because then now, like I said, so then this thing is going to be false, either right is equal to n, or this is outside the bounds, which is what we want, right? Because then now in this case, then now the distance, because it's exclusive, is just going to be right minus left, right? Yeah. And of course you have to take the max, is it? Oh, minimum. Oh, I'm wrong. Oh, wait. Well, this is the most you're keeping. So actually I skipped a step in that, I probably should talk about it, but yeah, it's okay. Y'all are smart, hopefully. But again, I jumped ahead without realizing that I'm reading it, whatever. But minimum removal is just the opposite of maximum keeping, right? So yeah, because you basically throw away everything you keep or you don't keep, and that's basically the idea. And then now just this, right? I mean, I may be off by 1, but that's the general idea. And we should be okay. Let's give it submit, and hopefully I didn't make a silly mistake just because I didn't really check the answer, or I didn't check for edge cases more specifically, which it happens. I mean, I don't know. But yeah, I mean, these are bounds I considered. I mean, there might be some stuff up if there were negative numbers, maybe I have to take an extra couple of seconds to think about it or something. And technically, you actually have to think about. I mean, in Python, I did not. But it probably is a good pattern to think about overflow, right? Because this clearly would overflow a 32-bit int, signed or unsigned. But that's the beauty of. And in C++, you have gotten a wrong answer if you try to implement it that way without considering the 64-bit int or something. But in Python, you do get that for free. That's it. I mean, as I said, there is sorting, so it's going to be n log n, but otherwise everything's O of n. How did I do it last time? Oh yeah, I did do the bisector. I mean, yeah, I did bisect right on this one, so I didn't do the bisect left. I mean, either way is fine, right? And as you can see, the code is just really short. I don't have to worry about, like the equal sign, or like less than equal versus less than, and like as a result, like this is a little bit different. Oops, how did that happen? And stuff like that. So I don't know. So for contest, this is what I want. But otherwise, everything is basically the same, right? Other than the code that is totally different, everything is basically the same. But yeah, that's it. That's all I have for this one. Let me know what you think. Thanks for watching. And yeah, stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.